Hi there! Last week we looked at a bunch of fun and useless C# features. If you missed it, the link's in the description. But here's the thing. There are more of these gems, and one of them is extra spicy. I'm genuinely hyped about this one. Think you can guess which feature I mean? Watch till the end and drop your guess in the comment section. Now, this one is really interesting, and I bet a lot of you use the product of it every single day but have never thought about how it's implemented. I'm talking about async code. What kind of magic happens when you use the await keyword? Well, it's actually magic. A magic method called getAwaiter. Let's create an async start method. And by the way, don't ever do this. Want to know why? Take a look at my unit task video. Here I'm writing a log, then waiting 1000 milliseconds, which is, well, a second, and then writing another log. So what will happen is we'll see the before awaiting message, and then after a second we'll see the after awaiting message. Simple. But I'm tired of working with milliseconds. Let's implement our own alternative to wait for seconds in coroutines. I'll just call it wait. I want it to store the number of seconds it should wait, and I want to initialize it from the constructor. The way to tell the compiler that a type can be awaited is not through inheritance or interface implementation. It's pure magic. I just need to create a method called getAwaiter that returns any type implementing the iNotifyCompletion interface. But note that we can't use the interface itself as a return value. Why? Because the magic doesn't stop here. iNotifyCompletion has only one method in it, onCompleted. But for an awaiter to work, it must have other things as well. Let's take a look at taskAwaiter, the awaiter used by C# tasks. The important parts here, apart from the onCompleted method that comes from the interface, are the isCompleted property and the getResult method. Similar to getAwaiter, these are magic, and without them, the compiler won't recognize the type as an awaiter. While I could have written a custom awaiter that follows some custom logic, it would take too long, so I'll just reuse the one we get from task. I can even use tasks internally. I'll convert the seconds float to a time span, and then I'll create a new task with the taskDelay method. And since task already has a getAwaiter method, I'll just return it in my method. Now in the start method, instead of taskDelay, I can create a new instance of my wait class and pass in the seconds as a float. Honestly, this is stupid. Let's make it more stupid. I once saw someone creating a float extension that awaits seconds. It was something like this. In a static class, I can write an extension method for a float that returns a task. Then inside, I can do something similar to what I did with the getAwaiter, but instead of the awaiter, I'll return the task itself. Now I can rewrite the start method. Instead of the new wait class, I can write my float and call the extension method, and it'll work. But what if I told you that we can go even more stupid than this? Remember that getAwaiter is not part of any interface? So theoretically, we can create an extension method for any type, telling the compiler that this type has an awaiter. Let's change the extension method. Instead of returning a task, I'll return the awaiter. I also need to change the name to getAwaiter, and as you already figured out, this is important for the compiler. Lastly, I'll return the awaiter, not the task. Now, behold, I'll remove the non-existent wait extension method invocation and we can await any float now. When I promise stupid, I deliver. And to prove to you that it works, I'll create a new game object to which I'll add the custom await component. Now, just run this code. First, we see the before awaiting log, and after 1.5 seconds, the after awaiting log appears. The next one is even more magical. Did you know C# has undocumented keywords? Not deprecated, not internal, undocumented. As in, they're not in the official docs, and IntelliSense won't suggest them to you. Let's start with makeref. I'll create an integer and assign a value to it. Now I'll use the makeref keyword to create a typed reference. And it's a weird looking one, isn't it? Typed reference is a struct that holds a pointer to a value and its type. But if we try to access something inside it, we'll find out that we don't have access to any of it. We have the regular object methods here. And don't look at the getType method, it will return the type of the variable, which is, well, a typed reference. But wait a second, it actually won't work at all. Why? Because magic. And the magic doesn't end here. We can't use it as a return type from a method, and we can't have it as an instance member. You might say, but Yuri, you know that ref structs can't be members of classes, only members of other ref structs. Same rules apply to spans, for example. Yep, but typed reference can't be a member of another ref structs either. Take a look. The span will work here. But let's get back to the data stored inside. How do we extract it? Well, more magic, of course. If we want to get the type of the variable, we can use the refType keyword. If we want to get the value, we can use the refValue keyword. Like with refType, we pass in the typed reference, but here's more magic. We just pass in a type, not a type of. Where else, except for member declarations, have you ever seen this syntax? I'll tell you, nowhere. But this is only a copy of the value, so if we change it and print the original number, it will still be 42. With refValue, we can also extract a reference. All we need to do is add the ref keyword before the type and before the refValue keyword. If I change this value now and print the original number variable, the value inside it will change. Let's see it in Unity. As always, I create a new game object and assign the component to it. After I run the code, you can see two logs. 42 for when we extracted a copy, and 12 for when we extracted the reference. So why would anyone use this? Honestly, almost nobody does, and probably nobody should. This was added for very low-level interrupt scenarios and some edge cases with reflection. If you're interested in diving deeper, there's plenty of info online, just not in the official docs. Finally, let's talk about a keyword that makes C# act like JavaScript. And I'm talking about dynamic keyword here. You are probably familiar with anonymous types. We can declare a variable with the var keyword and then say create a new object with those fields. And we can do whatever here. A string, an int, or even a delegate in form of action or func. Then I can execute the print method from this type and even provide it with a string from within the anonymous type itself. Let's run it in Unity. And I already created a game object with the relevant component, so I'll just run it. And here we see that it worked. The console prints the message. Now, if we're going JavaScript style, let's go all the way. Because in JavaScript, you can assign new members to an object at any time. But anonymous objects do not support it. You can see from the IDE tooltip that the object is strongly typed. It has a name of type string, a value of type int, and a print of type action. This is where dynamic comes in. By replacing the var keyword with a dynamic keyword, the code suddenly compiles. So now we can even print this new value. You know what? Why bother using the old method? Let's use the one I've never declared. I'll invoke a method called printNewValue. And then I can even fetch a string from a method called getSomeString. Want to see it in action? And boom! An exception. The exception happened the moment I've tried to create a new member called newValue. It haven't even reached the non-existent methods I've tried to invoke. Because if you look at the error message here, it says that this strongly typed anonymous type does not contain a definition for newValue. So behind the scenes, it is still a regular anonymous type. The dynamic keyword just hides it. So why does this exist? Mainly for COM_interrupt, talking to Excel, Word, or other Office applications. Also useful when dealing with JSON from untyped sources or reflection-heavy code. But in game development, in Unity, you almost never need it. And even if you do find this approach intriguing, I'm happy to say that this won't work with Auto-CPP code because it relies on reflection emit, which is not supported in IL2CPP. It will also won't work if you're targeting .NET Standard. So in Unity, it'll work only if you're targeting .NET Framework with mono-scripting backend. But please don't use it. Have you managed to guess which feature I love the most from the list? Drop a comment. Also, if you think I've missed something interesting, let me know. I'd love to learn more of these cool features. By the way, don't forget to like and subscribe. Keep on creating, and I'll see you in the next one.